This is about iron and nickel. In this picture here, we see nickel has a shape much like iron. And in Blender software here, I can rotate this around and things. Let's try the y-axis. So we see there's two loops of protons in white and the blue neutrons. And the difference between the nickel here and the iron is, you notice there's this one more proton in the center. That iron just has this one, and nickel has both of these. Now they're both ferromagnetic because they have two loops that are coaxial. Just nickel is not as good a ferromagnet as iron is because it's off-center a little bit here. So we can also take away all of the neutrons, and then I can show you just the protons. And then I could just select all of them and rotate them around the z-axis here. And you can see there's the two loops of protons are coaxial, and the four more for nickel there are shown. So this forms something which I'm going to be discussing, in which these nuclei are going to be discussed in terms of the NMR, nuclear magnetic resonance, and the precession is caused by something I propose as the non-crossing theory. Here it's really replacing the old Lenz law. And now here on the left, you see there's a bar magnet number 1, and on the right there's a bar magnet number 2. I'm just taking one atom on the right here and another atom on the left here. And you can see that there's a ring current going through nickel or iron, and there's also a ring current in both the rings. And if they're both going the same way, it's magnetized. If they're both going opposite directions, it's demagnetized. Now, the south pole, let's say, is on the left, and then the north pole's on the right end of this iron atom. And this is a domain of a crystal of iron in which one loop has the protons bonded to local electrons in red, and the other loop has its protons paired with electrons in the other bar. That is the amazing thing about iron. So the currents are all going clockwise here. In terms of the electrons are flowing clockwise. The proton ring current is flowing clockwise. So this is lined up for like an NMR experiment, where you can have a glass tube in the middle there, and then this flux, these Webers, Teslas, magnetic flux, where one line of flux is a pairing line from one proton here to a remote electron over here. So you see this vortex kind of shape, funnel shape here, going from the far ring, passing through the close ring, spreading out to a bunch of electrons that are in an eddy current. And then vice versa. For the other side, the south has the local domain with the local electrons. And then the other ring, for example, on this yellow one marked, that one's connected to an electron on the other bar magnet. And this causes a non-crossing to be enforced so that all this is spinning around the same direction. None of these lines are crossing each other. It's like two windmills synchronized so that the non-crossing law is held up to replace the Lenz law. So I have a couple other notes I'd like to bring up right now. And for one thing, a Weber is about 800 billion lines of flux. A line of flux connects one proton to one electron. And each line of flux is really a 3D bond membrane, as you could see in the website ferronuclear.blogspot.com. So I'm just attempting to make a finer physical description than is provided by merely energy considerations. It's not good enough just to have the Hamiltonian correct. You have to look at these three dimensions in the membranes and these lines of flux having three dimensions, being two space dimensions and one time-like dimension going the other way, much like for gravity on a small scale. And thank you very much. This is Alan Folmsby.